106, scientific notation. A number is written in scientific notation when it is between 1 and 10 and written as a product of 10 times a power, or 10 to a power. Product means multiplication. So an example would be like 5 times 10 to the fourth. So 5 is a number between 1 and 10, and I have a product because I'm multiplying 5 times 10 to the fourth power. So another example would be like 9.78. 9.78 is between 1 and 10, and then I have times 10 to the negative 2 power. A non-example, so something that would not be an example, would be like 25 times 10 squared, because 25 is not a number between 1 and 10. So we're going to look at just a couple of really simple examples. I can read the words 2 million, and then I'm going to write the number in standard form. So standard form just means write out the number. And you've probably seen some things about scientific notation before. I know that my decimal's right here, and I want to make it over here, right after the 2. I want there to be only one digit in front of the decimal, and I want that number to be between 1 and 10. So if I take 2, that's a number between 1 and 10. I have to move my decimal 1, 2, 3, 4, 5, 6 places. So my answer will be 2 times 10 to the 6th. The next one, I have 5 thousandths. So that's 0 point. The first place holder, my 0 is a 10th place. And then a hundredths place. Next is thousandths. And I want there to be 5 thousandths. So I'm going to put a 5 there. So now I have to look at what's happening to my decimal again. My decimal starting out here, but I want there to be a number between 1 and 10 in front of that decimal. So I need this number to be in front of that decimal. So now I have to figure out what power. So I'm moving my decimal from here, 1, 2, 3 places. I want it to be here now. And that means if I'm moving it 3 in that other direction, because I have a really small number, I'm going to have a negative exponent. So if I have a really big number, I'm moving it and getting a positive exponent. If I have a little number, I'm moving it the other direction, and it's going to be a negative exponent. We're going to look at a bunch of examples. Helps to look at more than one and have different signs on them, and we'll figure it out. So let's see. Right now my decimal's here, and I want to move it over between the 3 and the 5, because then I will have 3.57. And 3.57 is a number between 1 and 10. Another way I always think about it is you want one digit in front of that decimal that's not a 0. So just one place times 10. And then we want to think about how many places. I moved it 1, 2, 3, 4, 5, 6, and so 10 to the 6th again. Okay, now let's figure out on the second one. I need to have just that one digit in front of the decimal. So I need to move my decimal from here to here, which is 2 places. So I'll have negative 9.8035. I moved it 2 places, so I have 10 squared. And these are both big numbers. They get positive exponents. Number 3, my decimal's at the end right now, and I want there to be one digit in front of it. So I need it to go right here between the 3 and the 2. So 3.24 times 10 to the, let's do 1, 2, 3, 4 places. So times 10 to the 4th. The last one, I already have just one digit in front of that decimal. Negative 2.34. It's already a number. If I think about the absolute value and just ignore that negative sign, it's already between 1 and 10. I only have one thing in front of that decimal. So it's already in scientific notation in that way, but we don't have a product of 10 to a power. So I'm going to write times 10, and I have moved it 0 places. So I'll write a 0 here for my exponent. So that's kind of a tricky one. So for 5, I want to write the number without a power of 10. So I'm going to have to move it the other way. I'm going to have to start out with scientific notation and then build the number. So 5 is 8.76 times 10 to the 10th. That means this decimal here needs to move to make a really big number. 10 to the 10th would be a big number. So I'm going to have to move to the right, and I need it to go 10 places. So past the 7 is 1, past the 6 is another 1. But if I want to keep moving that decimal, I need to add in zeros as placeholders. So we have to figure out how many zeros to add in. So I need to move 10 places altogether, and I've already moved 1, 2. So that means I need to add in 8 zeros. So now I'll go back and add in some commas to make my number really clear. And we're done. For 6, it says 5.25 times 10 to the first. So we're making a bigger number again. We're moving just one place. 10 to the first is really just 10, isn't it? 10 to the first equals 10. So it's really just like multiplying by 10. So I will move the decimal one place, and I will have 52.5. On this last problem, I have a negative 9th exponent. That means I have a really small number, so my decimal is going to have to go the other direction. And I'm going to have to move it 9 places. So I have one place past the 5, and then I have to think about how many zeros I'd have to add in. I'm going to have a decimal and then some zeros, and then eventually a 5, 8, 9. So I'm going to move it one place past the 5, and then I would have to add in 8 more zeros to get up to that decimal. So 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then 5, 8, 9. And I'm going to put a 0 in front of the decimal too, because I'm allowed to do that. It just makes it look nicer. Let's double check this one, because this is a harder one for people to see. So my decimal started out here, and I wanted to move it 9 places. So here's 3 places, and 3 more places, and 3 more places. So I did move it 9 places. So you can always go back and take your standard form number and convert it back and just make sure you have a right answer. For number 8, we're asked to order from least to greatest. So in order to get a number ordered from least to greatest, they're already in scientific notation. We know the one with the smallest exponent on 10 will be the smallest number. So I have 10 to the 8th, I have 10 to the 9th, I have 10 to the 8th again. So both of these numbers that are 10 to the 8th, those are going to be the smallest two numbers. So we have to figure out between these two which one's smaller. So 6.2 is definitely smaller than 7.9. So first will be 6.2 times 10 to the 8th. Then we'll have 7.9 times 10 to the 8th. And then 7.1 times 10 to the 9th. 9th power is my biggest exponent there, so that's going to be my biggest number. For number 9, they're asking which is the smallest. So I need to look for the smallest exponent. So my exponents are -2, -5, 2, and 3. So be really careful. The sign does matter. It doesn't matter that 2 is smaller than 5. I have to look at the sign. So if I have a -4, -5, 2, and 3, my -5 is going to be the smallest. So -5 is smaller than -4, 2, or 3. And I could prove that on a number line, right? Here's my number line. Here's 0, 1, 2, 3. Other directions are negatives. 1, 2, 3. This is -4. This one's -5. The smallest number is going to be on the left. I feel like this is one of those easy things that's easy for people to screw up. Man, my handwriting is really bad on the surface today. The smallest number is on left. Sorry about that. So my smallest number would be 9.2 times 10 to the -5th. Last two. The lesson wants you to compare some numbers. And these are some of the problems that you'll be doing on the quiz. And they're going to give you multiple choice answers where you're talking about how much bigger or how many times bigger one number is than the other. So that's kind of what they're looking for here. So first I would look at the 9 and the 3. And I know that 9 versus 3, it's going to be 3 times bigger. So I'm going to write 3 times, but then I also have to look at 10 to the 5th versus 10 to the 3rd. So if I have 10 to the 5th versus 10 to the 3rd, I need to figure out how many decimal places bigger that is. So that would be 10 to the squared decimal places bigger. 10 to the squared is 100. So I have 3 times 100, which is going to be 300 times bigger. Times bigger. So that's kind of what they're looking for on these. I know when they say compare, it seems like it's pretty open to interpretation, but your answers are multiple choice. This is the kind of information they're looking. So again, we looked at the 9 and the 3, and we divided. And then when we were looking at the 5 and the 3 over here, we were looking at how many decimal places bigger. And we did that by subtracting. And this is going to be something that you do more in the next lesson. We look at multiplying and dividing scientific notation numbers. We'll do the same thing on 11. I want to look at the 6 versus the 3 and figure out how many times bigger, and that's 2 times bigger. So the 6 and the 3 we're dividing again. And then we're looking at 10 to the 5th versus 10 squared. We want to know how many bigger places that would be. So that means we're going to be subtracting. So we're going to subtract those exponents. And 10 to the 5th, so 5 minus 2 would be 10 to the 3rd. And so 10 to the 3rd is 1,000. So 2 times 1,000, or 2,000 times bigger. Thank you so much for watching. I hope this helps you on your Canvas quiz. Have a great day.